So the whole goal in solving systems of equations is to find the intersection point, the point that where both lines cross. That's considered the solution to the system. So in this section, in section 5.2, we're not actually going to be graphing anything, but you have to imagine that what we're doing is taking two lines that are on the same exact x and y axis. So that, say this is line 1 and say this is line 2. And you're trying to find the solution, which is the point of intersection. That solution is the point where these two lines intersect, where they cross. In this particular section, we're not going to be graphing, though. So we're not going to be drawing the one line, drawing the other line, and then finding the points they cross. We're going to be using an algebraic process to find the ordered pair that they cross without actually graphing at all. And it requires a couple steps. It's called substitution because you're going to be replacing in things for other things. So you're going to be replacing numbers in for variables and variables in for numbers. That's called substitution, when you replace something with something else. And it requires these 4 steps. Step 1, you have to set up one of the equations that it says either y equals or x equals. Step 2, once you have that done, then you substitute the expression from step 1 into the other equation. Step 3, you solve for the variable that's left, and step 4, replace the value you solved into the original equation to find the other variable. So all 4 of these steps sound like completely confusing until we start an example to try, and I'll show you how this works. So in example 1, we're going to be solving the system of equations not by graphing, but by substitution. And for this process, you actually do have to show pretty much all of your work. This is not something that can be done in your head, and this is not something that can be done with a graph. You're going to do everything algebraically, which means you're going to be using algebra to solve it rather than use a graph paper to graph it. So the first step in solving a system by substitution is taking one of the equations and making it so that it says y equals or x equals. So in the first equation here, it already is in y equals form. So if you look at this equation, this is already in y equals form. In step 1, it tells us to make sure that one of the equations is in y equals form, and if it's not, to put it into y equals form. Well, since this is already in y equals form, then we can just go ahead to step 2. Step 2 says substitute the expression from step 1 into the other equation. So substitution works only when you have things equal to each other. So like, for example, when you have a substitute teacher in your class. So say I'm out and another teacher comes in, whether it's a substitute that doesn't teach another class in the school, or it is another teacher that teaches a different class in the school. When a substitute teacher comes into your class, they're replacing that teacher either for the day or for the week or however long, and they are equal in that they both have a degree of some sort to teach education. So substitutes can replace each other. And that's what's going to happen in this process. Because y is equal to 3x plus 2, these two things are equivalent. So what that means is anytime you see a y, you can actually use substitution and replace 3x plus 2 into that. I need everyone to focus because this process is incredibly difficult to pick up if you're not paying attention from the very, very top. So y is equal to 3x plus 2. Because of that, I can use substitution, and when I see a y in the other equation, which I see it right here, I'm going to be replacing 3x plus 2 in for that y. So step 2 says, substitute the expression from step 1 in the other equation. So the equation is x plus 2y equals 11. Please write this down with me. But because y is equal to 3x plus 2, I'm taking 3x plus 2 and I'm going to replace it in for that y right there. So this will say instead of x plus 2 times y, it's going to say x plus 2 times 3x plus 2 equals 11. Now take a second to write that down and look what I just did. What did I just do in that step? Really look at it, because if you weren't paying attention, or if you were but you're confused, try and look at what happened from this step 1 to this step 2, what did I do? Because I see x, I see plus in both of them. I see 2y in this one, I see 2, and then parentheses, this stuff in here, I see equal to 11. So what happened from step 1 to step 2? What did I do? Alex?
You substituted the 3x plus 2 into the equation.
Yeah, so exactly. I took the 3x plus 2, which is up here, and I substituted it in for y. And I could only do that because the equation was set up as y is equal to 3x plus 2. When you have things that are equal to each other, you can use substitution and replace them back and forth in for the other expressions, and it's still considered equivalent. Now that we have this equation here, x plus 2 times 3x plus 2 equals 11, what we're going to do in step 3 is solve for the variable that's left. I can take this equation and I can solve it for x. But the first thing I would have to do is use the distributive property and multiply this all by 2. So when I do that, I'm going to get x plus 2 times 3x is 6x plus 2 times 2 is 4. So we get the equation x plus 6x plus 4 equals 11. Next step would be to combine like terms. That means take all of the x's and put them together in one term instead of having them separate. 1x plus 6x is 7x. And once I do that, now I have a two-step equation to solve. To solve this one, I would get rid of the plus 4. I would do that by subtracting 4 from both sides. 11 minus 4 is 7. I'll finish my work up here. This will say 7x is equal to 7. And this one's going to work out nicely, which these are going to be developed so that they do. You divide everything by 7, and you're going to get x is equal to 1. Now remember, when you're solving a system of equations, your whole entire goal at the end is to find the ordered pair where they, I'll just say cross. So right now, we have part of the ordered pair. Every ordered pair is in xy form. Right now, we know that the ordered pair where they cross is at x is equal to 1. So I have found, through substitution, that the ordered pair where these two lines cross is going to be at 1 on the x-axis. But now we have to figure out what the other part is going to be. We need to figure out what the y number is going to be. So now that we have that x is equal to 1, I look back at the original equation, so I'm looking back up here. And you choose an equation that's easier, and you're going to be completing step 4 at that point. It says replace the value from step 3, that means replace x is equal to 1, into one of the original equations to find the other variable. We need to figure out what y is equal to. To figure out what y is equal to, we now know that x is equal to 1. So you're going to choose the easier equation. I think that this first equation is easier because it's already set up to be y equals 3x plus 2, but you could use the other one, it doesn't matter. And we know that the solution is going to be when x is equal to 1. So what I will do then is replace 1 in for x, and then solve, and I'll have my y value for the problem. 3 times 1 is 3. 3 plus 2 is 5. The y coordinate for this solution point is at 5. That means that altogether the final answer for this problem is 1, 5. This is the point where these two lines cross. We didn't have to graph it at all. We were able to solve it through substitution. It's a long process. It requires these 4 steps. And this is an easier type of problem because step 1 says make the equation either y equals or x equals, and it was already done for us. So then we just could move down to step 2. We used substitution. We solved for one variable. Then we took that variable, replaced it into one of the equations from the beginning to solve for the other variable. Remember, the whole goal in solving systems of equations is figuring out the ordered pair, the x comma y ordered pair where these two lines intersect. So I know without having to even graph these at all that the point that they intersect is at 1, 5. Now don't forget, you can always check your answer, and I think that it's really important to do that, to take the time. To check your answer, we will replace in a 1 for x and a 5 for y. For the first equation, this will say 5 equals 3 times 1 plus 2, and that works. 3 times 1 is 3. 3 plus 2 is 5. It works for the first one. And for the second one, it'll say 1 plus 2 times 5 equals 11. That also works. 2 times 5 is 10. 1 plus 10 is 11. So in this section, you can actually know for sure if you get the answers right or not, because your solutions will work when you get them in the end. Let's try number 2 together. So in number 2, we're doing the same process. We're solving this by substitution. Step 1 for the substitution step is to set up one of the equations so that it's either y equals or x equals. Well, actually, both of the equations in number 2, if you see here, they're both set up, and they already have y equals, so we don't have to worry about step 1. We can just move down to step 2. Step 2 says substitute the expression from step 1 into the other equation. So let's look at this first one. Y is equal to 2x. Since y is equal to 2x, I can take the y in the other equation and replace it with 2x. That's the substitution step. So instead of just saying y is equal to negative 3x plus 5, I can actually say 2x is equal to negative 3x plus 5. What I did right here was use the substitution step in step 2. I replaced in 2x in for that other y, and now I have an equation that I can solve. Solving these equations will always look a little bit different. In this case, I want to move this negative 3x to the other side. I'm going to do that by adding 3x to both sides. And I'm going to get 5x equals 5. And then when I solve this one by dividing both sides by 5, I'm going to get x is equal to 1 again, coincidentally. So that means that these two equations do cross, and they are going to cross on the x-axis when x is equal to 1. Now you have the choice. You can choose one of the two equations, and you're going to replace 1 back in for x and solve. I feel like the first one's easier because it's just y equals 2x. And since we found that x is equal to 1, you replace a 1 in for x, which means y is going to be equal to 2, since 2 times 1 is 2. Altogether, the ordered pair where they cross is 1, 2. This would be considered the solution to the ordered pair, to the system. All right, so then we could just verify that by replacing in x is equal to 1 and y is equal to 2 into these equations. We'll get 2 equals 2 times 1. That's true. And then we'll also get 2 equals negative 3 times 1 plus 5. Also true. Anyone have any questions on that so far? All right, so this is definitely a new process. You're going to have to make sure you just practice. And with practice, it'll get a little bit easier if you're confused. So let's try the next one, number 3. The first step in solving a system by substitution is making sure that the equations are in either x equals or y equals form. Looking at number 3, the equations are x equals 3y plus 5 and 2x plus y equals 3. So this one's a little bit different because it actually already has an x equals, but we're not used to seeing equations in x equals form. It's usually y equals. But we can do the substitution step because this one is solved for x. What I'm going to do is replace a 3y plus 5 in for x in the other equation. So where I see x in the second equation here, I'm going to replace it with a 3y plus 5. So instead of just saying 2x plus y equals 3, I'm replacing in 3y plus 5 in for x here. When you do the substitution step, you'll be taking the equation and making it longer because you're replacing more stuff in for just that one single variable. I'm able to do that because these two things here, these two things are equivalent. Because they're equivalent, that means that you can set them equal to each other. You can replace one in for the other. Once you do the substitution step right here, now it's time for you to solve this equation. Solving this equation would first require us to distribute, so I'm going to multiply everything by 2. 2 times 3y is 6y, plus 2 times 5 is 10. I'm left with 6y plus 10 plus y equals 3. I can combine like terms here. 6y plus 1y is 7y. And then I solve this two-step equation by first getting rid of this plus 10 by subtracting both sides by 10. And 3 minus 10 is negative 7. I'll divide both sides by 7. And I get y equals negative 1. Now remember, the final solution to the system is an ordered pair in xy form. We have just discovered that the y value of the solution is negative 1, so I can insert the negative 1 in for y there. Now we have to solve for x. We have to figure out what x is equal to. Now we go back to the original two equations, x equals 3y plus 5, or 2x plus y equals 3. Choose the easier equation, whatever one you think looks easier to you. I believe it's going to be the first one because it's already in x equals form. X equals 3y plus 5. And we have now discovered that y is equal to what? Negative 1. So I'm going to replace in a negative 1 for y and solve for x. And then that will be the x coordinate of the solution. Well, 3 times negative 1 is negative 3. And negative 3 plus 5 is equal to 2. So now I know that the x coordinate is 2. The y coordinate is negative 1. So this is where these two lines cross. You could again take the time and replace in 2 for x, negative 1 for y, and make sure it works for both equations. So this would say 2 is equal to 3 times negative 1 plus 5. That works. 3 times negative 1 is negative 3. Negative 3 plus 5 is 2. And then you can do the other one by doing 2 times 2 plus negative 1 equals 3. Also works. 2 times 2 is 4. 4 plus negative 1 is 3. So you can verify that your solution is correct at the very end by plugging in the numbers for x and y. All right, let's flip this over to the next page. There's a bunch of practice problems here. I don't want to do too many. I want to make sure that everyone's on the right page. So let's just start with numbers 1 and 3 actually for now. So right now, do 1, skip 2, and then do 3. So let's try numbers 1 and 3. I'll give you a few minutes. We'll go over the answers, and then we're going to do 2 together. Okay, so you're over here at 4 plus 4 y is negative 8, right? Alright, so we're going to solve for y, so subtract both sides by 4. Mm-hmm. Yep. You get 4y equals negative 12. And you're going to get rid of the f. And you're, yeah. Okay, it's your show one?
Yeah.
I'm going to be honest, I know why. You were on your phone while I was going over it. I kept trying to get your attention, but you weren't paying attention to me. You were paying attention to your phone. So now you missed the entire 4-step process,
I
which
was
is...
watching the last 2 ones.
Yeah, I know, but when I first went over it, it's like I go into depth about why I'm doing what I'm doing. Like, it's hard to follow if you're not following from the very beginning. I try to get everyone's attention by saying that. So when I'm going over, really pay attention because it's going to take me just as much time to explain it again. So I'm not going to do it right now because I'm running out of time. But as I go over it, please pay attention and watch so that you can follow along and you're not going to be lost. Because what you're going to do is each day you don't understand. It's going to get harder and harder. So you're going to first multiply 4 times x minus 5. So you're going to distribute that 4 to get rid of the parentheses there.
Yeah.
So you're going to write down 2x by 2x. And then 4 times x is 4x. 4 times negative 5 is minus 20. Equals negative. And now you're going to solve this equation. Solve it for y.
Wait, what?
4x.
Oh shit.
I'm sorry, 2y. 2x plus 4x is 6x.
Wait, what did I do?
6x minus 20.
No, I didn't mess up.
Each x equals, so it goes to the x spot, not the y.
Um,
See how it's x in the beginning? You have to follow the x or the y.
on the right-hand side,
It's like you got the positive, you got the
now you know what x
x equals 5y.
Yo, this one is one of your pictures.
Oh, do you understand?
I understand.
So you get 2 for x, so right there, 2 for that. So now you have the x. Now what you need to do is replace that into the x.
I'm literally just a math
You now know x is 2. 2 minus 5 is 8.
so good.
That's how you get by putting that number back in. Alrighty, let's go over these answers and see how you did. So in order to solve these problems, you have to have one of the equations already solved for a variable. This variable right here, y equals, it's already solved, meaning that you don't have to do anything in order to do substitution. The reason why I skipped number 2 is because it says y minus 4x equals and 4x plus 2y equals. Neither one of these equations has y equals already solved or x equals already solved. So that one requires more steps. Because this is already solved for y, we can begin the substitution step, which would mean take x minus 5 and substitute it in for what it equals in the other equation. Well, because it's equivalent to y, guys, we can replace in x minus 5 in for that y right there. So what the second equation will turn into is 2x plus, instead of 4 times y, it'll be 4 times what y is equal to. Y is equal to x minus 5. This is called the substitution step because we're substituting what y is equal to in for that spot right there. Now we have an equation that all has one single type of variable. All of the variables you see are x's, so that means that you can now solve this equation for x. The first step you should always take is getting rid of the parentheses. You'll do that by distributing 4 to both numbers. This becomes then 2x plus 4x minus 20 equals negative 8. Now this just requires the skills that we learned previously at the beginning of the year when we were solving equations. 2x plus 4x is 6x. So we get 6x minus 20 equals negative 8. We'll undo minus 20 by adding 20 to both sides. And we'll get 6x equals negative 8 plus 20 is 12. Then we divide by 6. And we're going to get that the solution will be where x is equal to 2. So now we have half of our answer. Your final answer will be an ordered pair. You have half of it right now. Right now we know that it crosses at 2 on the x-axis, but we have to figure out what y is going to be. You go back to the very beginning equations. I'll just erase all this mess that I made. And you take a look at both equations and you pick the one that is easier to you. And I would definitely say the first one is easier because you're trying to solve for what y is equal to. And the first equation is set to be what y is equal to. The equation y equals x minus 5 is the easier one to use. You put 2 in for x and you solve for y. We're going to get y is equal to negative 3. That means your final answer is going to be 2, negative 3. That's where these two lines cross. And we solved it with substitution. We're now going to skip to number 3 so that we can go over this same type of process again. We'll come back to number 2 when we have more time tomorrow. So number 3, your first step in solving systems of equations by substitution is making sure that one of the equations is already solved for x or y. The first equation is solved for x here. So I can begin substitution. X is equal to y minus 3. So what I will do is replace in y minus 3 in for x in that second equation. So instead of it saying 5x plus 3y equals 1, you're going to take this x here and replace in what it's equal to, which is y minus 3. Once you do the substitution step and you replace in what x is equal to, you should see that all of the variables you have left are the same. I see y's in the equation, which means I did not make a mistake. Once you do substitution, you'll never see different variables, but they will all be the same. Once you did that, now you can just go ahead and solve it by distributing. And then solving by combining like terms. 5y plus 3y is 8y. I have 8y minus 15 equals 1. I'll finish my work up here. I would add 15 to both sides. I get 8y is equal to 16, since 1 plus 15 is 16. I divide everything by 8, and I get y is equal to 2. I now have half of my answer. I know that the y value for this point is at 2. Now I need to figure out what x is equal to. You go back to the original equations, and you pick the one that's easier. Which equation looks easier to solve for x? Yes, I agree. It's already in x equals form. So we take this equation, x equals y minus 3. We already found that y is equal to 2, so we'll put in a 2 in for y. X x is equal to 2 minus 3, that means that x is equal to negative 1. That means your final answer here is negative 1, 2. Your whole goal in solving these problems is finding the point of intersection. And that means you're going to have two numbers as your answer, an x number and a y number. When you do substitution, you're going to be finding the first one, whether it's the x number or the y number, it depends on the problem. And then once you find that answer, then you can replace that back in to find the other answer. Now, number 2 does look a little bit more difficult than the rest of them because number 2 does not have them already solved. But number 4 does. So let's actually just try one more problem today. Let's try number 4. It's pretty quick. We have y equals 3x plus 14 and y equals negative 4x. I'll give you a couple minutes. We'll go over it and call it a day.
You say 4.
Yep, number 4. All right, so number 4 is a little bit different because both of the equations are actually solved for y. So when you go to do the substitution step, it's kind of interesting because since y is equal to 3x plus 14 and y is also equal to negative 4x, what ends up happening is that you're going to be setting these equations equal to each other. You're going to take the 3x plus 14 in this one and replace it in for y in this one, so it's going to look like this. 3x plus 14 equals negative 4x. Once you have that substitution step done, then it's time to solve for the variables, and we're solving for x. Because the x's are on both sides, you have the option to either subtract both sides by 3x or add those sides by 4x. I don't usually like to do it this way, but I'm going to move the x's over here since if I did it the other way, then I would be left with 0 on this side. But I have then 14 equals negative 7x, and then to divide both sides by negative 7, I'm going to get negative 2 is equal to x. So I have my x answer is going to be negative 2. Now I'm going to solve for y. Looking at the original equations, y equals 3x plus 14 and y equals negative 4x. I think the second equation is quicker than the first one, so I'm going to use that. Y equals negative 4x. I found that x is equal to negative 2. So I replace in negative 2 in for x, and negative 4 times negative 2 is a positive 8. That means that the y value for that ordered pair is at 8. You can always verify your answers correct by replacing in negative 2 for x, 8 for y, and making sure that it works out. And then it will. You'll see that it will when you do that. And you will know that you got the problem right.